Hello everyone, my name is Grisha. I work in the YTsaurus team. YTsaurus is a data storage and processing platform that went into open source about a month ago. In order to make it easier for users to get acquainted with our system and start using it, my colleagues and I decided to hold a series of webinars in which we will talk about the operation of our system, about its device, and about examples of its use. And today we will have the first of these webinars. Let's start by talking about the general capabilities of the system. Let's talk about the components of which it consists. Then, we will deploy a small YTsaurus cluster locally using the Minikube utility. Then, we will move to the demo cluster and look at examples of how our Cypress file system functions, which is the basis of our system. We will look at how it is possible to store data, how it is possible to manage data storage in Cypress. Let's see how the Cypress tree is represented in the web interface of YTsaurus. Then, we will talk about data processing and consider how it is possible to run operations on data in our cluster using the MapReduce paradigm, as well as consider the computing engines of CHIT and SPIT, which can simplify the analysis of data stored in our platform. Finally, we will talk about how many users can use our cluster at the same time. Namely, we will talk about how disk and computing resources are divided within the cluster, and we will talk about how you can configure access rights to directories and a table. In the end, we will be happy to answer all your questions, so do not hesitate to ask questions during the report, or just any questions about YTsaurus through Zoom. My colleagues will answer some of the questions in the chat during the presentation, and I will answer the most interesting ones after the end of my presentation. So, let's start by talking about what is generally included in the YTsaurus. As I have already said, the basis of YTsaurus system is the Cypress file system, which is a kind of tree-like file system that contains both all user data and various system objects that affect the behavior of the system. The key object in the Cypress file system is a table in which it is possible to store various schematized or non-schematized data for subsequent processing. There are two types of tables in Cypress, static and dynamic. Static tables are designed to store large amounts of data that are immutable. On the one hand, such tables are the cheapest per megabyte of storage, but on the other hand, they do not allow efficient data modification. The only operation of changing a static table that is effective is to add some large amount of data to the end. In case the data stored in the system needs to be changed frequently, dynamic tables are supported in YTsaurus. Such tables are where both the key and the values can be some schematized data that is stored in one or in different columns. And as is usually the case in QL repositories, for dynamic tables, an efficient change request by key, reading by key, or reading some key subset is supported. Such tables are much more expensive based on the megabyte of storage, but at the same time, they allow you to efficiently update data, including transactional. The computing resources of the YTsaurus cluster are managed by a distributed fault-tolerant scheduler, which allows users to run various loads on the cluster, which is designed for data processing. Various computing engines can be used to process data in YTsaurus. Historically, the very first one is MapReduce, that simply implements the paradigm of the same name. The user can write arbitrary code of the MapReducer and run a MapReduce operation on top of the data that will perform the required transformation. In fact, unlike the classic MapReduce, the YTsaurus system supports a richer model of operations. There are separate map operations, there is a reduce operation, there is a separate sorting operation, an operation that allows you to perform a merge of some tables and some others. Despite the fact that it is a fairly rich model of calculations, it is not convenient to implement an operation or several operations manually in all situations. For example, for analytics, you may need to filter data by some predicate or calculate some aggregates, and in such a situation, you do not want to write the same type of code every time. In order to simplify such scenarios, YTsaurus system supports an YTsaurus engine that allows you to perform SQL-like queries on data, converting a query from a query into a sequence of map operations or computational operations of another type, which will be automatically executed, and the user will receive as a result the result of calculating the entire graph. This allows the user to conveniently execute some simple queries on top of the cluster data. Both YTsaurus and MapReduce for bulk calculations that allow you to efficiently process huge amounts of data, but at the same time, have some delays in launching a specific operation. Therefore, if it is necessary to quickly perform some calculations on a small amount of data, MapReduce and YTsaurus may not be the most efficient ways to achieve what is desired due to the high additive constant for running a single operation. And in order to fix this shortcoming, two efficient memory engines are supported in YTsaurus system, which are designed for low-latency processing of not very large amounts of data. These engines are CHIT and SPIT, also known as ClickHouse over IT and Spark over IT. ClickHouse over IT is a technology that allows you to run on the computing resources of the YTsaurus cluster, some small cluster of the well-known ClickHouse database, which will be able to see the data contained in the log. Thus, for effective analytics, it is possible to save the required data in the table to go abroad, then deploy the ClickHouse cluster to login, and set a query directly to the ClickHouse, which will be efficiently executed in the engine memory. The second in-memory engine to go beyond is SPIT or Spark over IT, which similarly allows you to deploy a small Spark cluster on top of the computing resources to go beyond, and allows the Spark cluster to see the data that go beyond is saved. Both CHIT and SPIT are fully compatible with the original ClickHouse and Spark data storage systems, so it allows you to transfer your processes from, for example, just ClickHouse to ClickHouse over IT without changing your requests. For Spark over IT, both the usual Java library for working with Spark and the Python library of PSpark, which allows you to work with the Spark cluster using Python, are supported. Three main interfaces are supported for working with Cypress and data processing systems in YTsaurus. First of all, there are languages which allow you to perform various operations on the cluster in the languages Go, Java, Python, and C++. Are the richest ways of working with a cluster in terms of supported functionality. However, again, this is not always convenient. For example, a user may just want to sort some table, and it is not very convenient to write some Python code for this every time. Therefore, in addition to the languages, the command line utility is supported, which allows you to perform some simple operations in the system. For example, it allows you to interact with the Cypress file system or run simple operations directly from the console. In addition to SDK and CLI, YTsaurus has a convenient web interface that allows you to view the Cypress file system, set YTsaurus and CHIT queries, and perform some simple operations on the table. Now, after we've looked at what there is in YTsaurus, let's look at a real cluster, and start with the fact that I'll show you how to deploy a local cluster of YTsaurus, a Minikube. So, Instructions for deploying a local cluster YTsaurus over a Minikube are in the documentation for our system, and some of what is described here have already been prepared by me, so I will not show it.
Инструкция по развертыванию локального кластера YTsaurus поверх Minikube находится в документации по нашей системе, и кое-что из того, что описано тут, мной уже подготовлено, поэтому я не буду это показывать.
But in the end, I'll show you exactly how the cluster is deployed and that something can be done in it. Usually, the YTsaurus is deployed in the Kubernetes system, and therefore, we decided that it was not worth doing some separate way to launch a small local cluster to try, but decided to simply provide instructions on how to deploy a small Kubernetes cluster locally, and deploy the YTsaurus cluster to try it. So, in order to try YTsaurus cluster, you will need some computer running the Linux operating system, on which you need to install Docker kubectl to work with the Kubernetes and Minikube. Minikube is a utility that allows you to turn your one computer into a whole Kubernetes cluster and deploy various code on it. Accordingly, from the point of view of YTsaurus, the Minikube is an ordinary Kubernetes cluster, in which various subsystems can be deployed by it. So, after installing the Docker kubectl and Minikube, you need to execute the Minikube start driver equals Docker command, which will raise the Kubernetes cluster, which will use the Docker system as the container execution engine. After the Minikube cluster has been installed, it is necessary to install the exit operator for the YTsaurus operator. This is a program that manages the execution of the YTsaurus in the Kubernetes cluster. It is responsible for deploying various components, installing, updating, and much more. To do this, you need to install the Helm tool that manages packages in Kubernetes C and execute the commands that are specified here. So, these steps have already been done, so let's make sure that the operator works. Indeed, I have one container running, in which the YTsaurus operator is running. Then, we need to select the cluster specification, which will describe exactly which cluster we want to run, the number of nodes in it, the size of these nodes and some other parameters, and run the cluster. The specification can be downloaded from our GitHub. There are several different specifications depending on how you want to get the cluster, but let's take the spec I have already prepared and try to install the cluster. After that, we will run the command to kubectl apply fspec YAML, and we can observe how the cluster unfolds. We see that two containers have been installed so far. This is the master, which is one of the main components of our system, and in which the Cypress file system is located. Also, the discovery service is being installed, which performs some internal functions of ClickHouse over it. Now the job is being executed, raising the master, which loads some basic data to the cluster and prepares it for further work. And after the completion of this job, it will be possible to start deploying all the components of our cluster. While the cluster is rising, I will tell you a little about what we are observing here in general. A DND is a data node, that is, a cluster node that will contain user data. End is an exec node, a cluster node, on which the user load will be executed. TND is a table node, on which the shards of dynamic tables will be located, which we will not talk about today. Also raised are ATP proxies that are used by YTCL to work with the cluster and the web interface, and RPC proxies that are necessary for dynamic tables. Also, the query tracker is deployed. This is some subsystem that is responsible for executing YTCL, chit and spit. We also have a scheduler running, which is responsible for distributing resources across the cluster, an agent controller, that is some part of the scheduler, and also a chit controller running, which is responsible for launching the ClickHouse cluster.
Cheat-контроллер, который отвечает за запуск кластера ClickHouse.
So it seems that our cluster has been installed, which means that we can get into it.
Мы можем на него взглянуть.
To do this, we need to configure network access to the web interface and to the proxies. Now I'm going to show only the web interface of the newly installed cluster, so we probably won't need the proxy address. Click on the link and see the web interface of the newly installed cluster. The standard login and password after installation is the admin login and the software password. So, we logged into the newly installed cluster, and we see that we really have such a toy cluster installed on my laptop. It can be seen that there is only one core for executing the user code, otherwise Zoom would not have survived this. There are 2 gigabytes of memory. Under the execution of user code, there is some amount of disk space for data storage. Actually, this is how we got a full-fledged YTsaurus cluster, and now I'm actually going to turn it off, and we'll move to another demo cluster, to which I added some data for the presentation, and look at how the Cypress is arranged, and how you can process data with the help of YTsaurus.
И посмотрим в нем на то, как устроен кипарис и то, как можно обрабатывать данные с помощью YTsaurus.
You can stop the cluster using the kubectl command with the indication of spic. After that, the cluster will slowly turn off.
После этого кластер будет потихонечку выключаться.
So, we move on to another cluster that is installed in the cloud, and it is actually almost identical to the cluster that you can get if you sign up for a demo on our website. Now I'm going to show and tell you a little bit about our Cypress file system, and then we'll look at the tools for calculations. So, now we are on the Navigation tab, which is just designed to view the status of Cypress. Cypress is a tree-like file system in which all YTsaurus objects are stored. But unlike the classic tree-like file systems, such as for example 44, which can be found when installing Linux, and ENS, which is supported by Windows, Cypress has a fairly rich functionality and allows you to do many different operations on the tree, including one of the most important functions of Cypress is transactionality. Cypress is supported by a very rich transaction model, and which allow, firstly, to perform various operations on it atomically, and secondly, allow using Cypress as a means for distributed coordination by analogy with Apache Zookeeper. So let's take a look at a small Cypress tree that I have in my demo cluster. I have a Who directory that stores data of various projects in some fictional company. For example, we have a directory that stores analyst data, and there is a directory that stores data for backend development. As you can see, there are still some nested directories in this directory. That is, we are dealing with a classic tree-like file system. One of the main objects in Cypress is a table. And we see that there really is some table in the home's backend directory, and the web interface allows you to actually look at its contents. Above, we see different method attributes of the table. We can see how many rows there are in it. We can see how much the table occupies in compressed and decompressed form. We can see with what replication factor it is saved, or with what codec it is compressed. We also see that we are dealing with a static table, which, among other things, is sorted by some columns. Below we can see the first few rows of the table. The interface also supports table navigation, so we can consider its various ranges. An important
Важным
property
свойством
of Cypress
таблицы является
is
то,
that
что
each of its nodes,
с
be it a
каждым его
table
узлом, будь
or a
то
directory, is
таблица или
associated with a
директория,
certain set of attributes that we can look at, for example,
ассоциирован
on the
некоторый
Attribute
набор
tab.
атрибутов, которые мы можем посмотреть, например, на вкладке Attributes.
Attributes of Cypress
Атрибуты
objects
объектов
can be
Кипариса
system
бывают
and
системные и
user-defined.
пользовательские.
The system
Системные
displays
показывают
various information
различные
in an
информацию в
object
объекте
or
или
allows you to
позволяют
control
узнавать
its
его быстрее.
behavior. For
Например, мы
example,
видим,
we see that
что
the object we are
объект,
currently observing
который
is
мы
a
сейчас
table,
наблюдаем, он
and we see
является
that it is
таблицей,
owned by an admin user.
и видим, что им владеет пользователь админ.
We see,
Видим,
for
например,
example,
что
that no
отдельно
locks
взятые
has been
какие
taken on
блоки,
it,
или
or we
видим,
see how much
какое
cluster
количество
resources it
субкластеров
consumes.
потребляет.
Some
Некоторые
attributes are
атрибуты
modified.
являются модифицируемыми.
For
Например,
example,
таковым
this is the
является
replication
атрибут
factor
replication
attribute,
factor,
by
меняя
changing
который
which we will
мы
change the
будем
table
менять
storage
скорость хранения
settings.
таблицы.
We can
Мы
lower the
можем
replication
повысить
level,
уровень
for
репликации,
example,
например,
if
если
we are
нам
not
не так
so
страшно
afraid of
потерять
losing
данные,
data,
но
but we want
мы
to spend less disk space.
хотим тратить меньшее количество места на диске.
In addition to the
Помимо
system
системных
attributes,
атрибутов,
the object
у
has a
объектов
set
есть
of
набор
user
пользовательских
attributes.
атрибутов.
They can be viewed
Их
separately
отдельно
on the
можно использовать
user's
во вкладке User
attribute
Attributes,
tabs, and these
и
attributes do not
эти
carry any
атрибуты
semantics
не
for the
несут никакой
system itself to go
семантики
beyond, but allow
для
the
самой
user to
системы
save some
YTsaurus,
information
но
about the
позволяют
object,
пользователю
which can
сохранять
be, for
некоторую
example, convenient
информацию
in
об
any
объекте, которая
process.
может быть, например, удобной какому-либо процессингу.
For
Скажем,
example, we
мы
can
можем
save a
сохранить
data
в
version or a
пользовательских
data
атрибутах
format version in
версию
user
данных или версию
attributes,
формата
which can
данных,
certainly be convenient in
что
real
безусловно
life
может быть
when some
удобным
process is built in a real
в реальной
company,
жизни,
and we
когда
periodically change the data storage
в реальной
scheme or the
компании
data
существуют некоторые
itself or
процессы,
something is
и мы
modified.
периодически меняем или схему хранения данных, или сами данные, или еще что-то модифицируем. А,
Also, in the
Также
web
в
interface, we can
веб-интерфейсе мы можем
perform various
проделывать
operations on the
различные
data in Cypress.
операции над данными в Кипарисе.
For
Например, мы
example,
можем
we can
взять
take
и
and delete a
удалить
table.
таблицу.
We can
Мы
create a
можем
new table, give it a name.
создать новую
We can choose a
таблицу,
compression code. We can also describe the scheme.
укажем ей какое-нибудь название, можем выбрать кодек компрессии, можем также описать схему.
For
Например,
example, we
у
will
нас
have
будет
one
одна
column,
колонка,
which we
например, с
call a key.
таблицом.
It will be
Она
of
будет
string type,
такого
and
типа,
add a value
и
column to it, which will, for example, have numeric types.
добавить колонку value, которая будет, например, иметь численный тип.
So,
Так,
we
ловим
confirm,
конфirm, и у
and
нас
we have a
появилась
new
новая таблица,
table,
в которую
in which we can
мы
save
можем
some data.
хранить данные.
In
Кроме
addition,
того, мы
we can
можем
copy the
копировать
table using the
таблицу
web interface, and can, for example, rename the newly created
при
table.
помощи веб-интерфейса. И можем, например, переименовать вновь созданную таблицу. Мы ее переименовали.
Also, with the
Также
help of the web
при помощи
interface, we
веб-интерфейса,
can
да, мы
actually
можем
run some
выполнить
simple
несколько
operations.
простейших
Here
операций
are
с
the tables.
таблицами.
For
Например, мы можем
example,
взять таблицу
we
и
can take a
отсортировать.
table and sort it. Click on the
Нажмем
More
на
Actions
кнопку
button,
More
select
Actions,
Sorting, and specify the set of columns
выберем
by which
сортировку
we want
и
to sort the table.
укажем набор колонок, по которым мы хотим отсортировать таблицу.
For
Например, мы
example,
хотим
we want to
отсортировать
sort
по
by name and
имени
region.
региону.
Click Confirm, and then we have a sorting operation
Нажмем
started.
Confirm, после чего у нас запустилась операция сортировки.
Here it
Вот она
actually
сразу
has
же
already
мгновенно
worked
отработала.
instantly, and we
И
can
мы
see
можем видеть,
that the
что
table has really become sorted by
действительно
name
таблица
and
стала
region
сортирована
columns.
по
It may
колонкам
not
name and
always be
region.
convenient to work with Cypress from the web interface, so let's look at how
Не
you can
всегда
still
может быть
work with
удобным
Cypress
работать
and
с
from the console.
кипарисом из веб-интерфейса, поэтому давайте рассмотрим, как можно еще работать с кипарисом из консоли. А
Namely,
именно
let's get
познакомиться
acquainted
с
with the
утилитой
itcli
YTsaurus.
utility. For
Для удобства
convenience,
буду
I will
показывать в
show in the
том
same
терминале,
terminal
который
that is in my Jupyter
находится в
notebook,
моем
in which I will
Jupyter
show
ноутбуке,
other
в котором буду
examples.
показывать другие примеры.
But this can
Но
be
это
done
можно сделать,
naturally,
естественно,
not
не
only
только
from
из
Jupyter,
Jupyter, но и
but
как
also
из
just from a
обычного
regular
пользователя.
console. The IT utility can be
Утилита
downloaded from the kip package,
найти может быть
and it
скачана
also has a
из
fairly rich
кит-пакета,
help, which
и
shows
также она
examples
имеет
of using
целую
its various
подрядную
commands.
папку, в которой указаны примеры использования различных ее команд.
Of course,
Разумеется, все
we will not
команды
discuss
мы
all the
обсуждать сегодня не
commands
будем,
today,
скорее
but rather
рассмотрим
consider a
несколько
few basic
базовых
commands for
команд
working
для
with
работы с
Cypress.
кипарисом.
One of
Одной
them
из них является
is the
команда
list
list,
command,
которая
which
позволяет
allows you
посмотреть
to view the
резюме территории.
contents of the territory. For example, we can see that the home directory contains a certain number of home directories of some users. Another important command is the itget command, which allows you to view some objects, and in the case of tables, for example, we can look at their attributes. Let's take the table and make enter, get on the path to the slash at table, where it means the set of all attributes of the table. Accordingly, here we can see all the attributes of the table. There are quite a lot of them here, and they are all systemic, and can be used for some deeper introspection of data problems. Also, with the help of commands itset and itget, we can edit various attributes. For example, we can make it set on some attribute and set its value to some string type, then read the contents of this attribute using itget. We can also view, of course, the contents of not only user attributes, but also system attributes. For example, we can look at the table schema by referring to the scheme attribute. A very important property of YTsaurus is that one tree contains not only user objects, but also system objects, which allows you to administer the system using the same commands that you used to work with data. Well, let's look at some example. We can look at the sysaccount directory, in which all system objects of user accounts are stored. At the same time, we can work with them using the same commands. For example, we can look at the backend attributes. And also, for example, in the sys directory, there is a directory of the nodes cluster, which contains a description of all the nodes of the cluster. Here we see all the nodes of the cluster. For example, we see that we have 3 nodes for data storage, 3 nodes for data processing, and 1 node for dynamic tables. We can query the attributes of a node to find out more about it. For example, we can see how many resources a certain node has. By editing some of these attributes, we can influence the behavior of nodes. For example, you can remove a node from a cluster using special attributes of decommission and band. But we'll talk about this in another webinar when we talk about system administration. You can also copy data, move it, and run operations using the it-cli. It's also easy to do all this. You can get acquainted with it by reading the documentation for the login command, executing it with command line arguments ---- help. All right. Having got a little acquainted with how data storage is arranged in the YTsaurus YTsaurus file system, let's look at how this data can be processed. Namely, let's get acquainted with the engines already mentioned, with chit, spit, ICL, and MapReduce, and the ICL tools allow you to simply run SQLic queries on top of the data. Therefore, to launch them in the web interface, YTsaurus has a special query tab where you can make requests to IFL and chit. Let's try to take and ask some kind of request. For example, we have a table that stores information about users of a certain system, and we want to find out the average age in this region and the number of different IP addresses for each user's region. We type in SQL query, select the engine, in this case it will be ICL, and run it. We see that the request has started to be executed, and if we go to the tab now, we can observe the production of the operation, in which this MapReduce has turned into. For example, there was some kind of production operation here, apparently intended for some kind of aggregation of intermediate calculation data. Well, we'll talk about the operation page a little later. Meanwhile, our request has been fulfilled. We see that it took 23 seconds, which, generally speaking, is not very small, given that the table is quite small. This is due precisely to the fact that each map-reduce operation has a fairly large overhead at the start of execution, so YTsaurus are rather more convenient tools for processing large amounts of data, whereas it is more convenient to use chit and spit engines for processing small amounts of data. Well, here we can observe the result of our query. There was really something calculated for each region. And let's also set a similar query in the chit engine. We see that we took the same SQL query, run it, and see that the request was processed almost instantly, because just a small table was completely read into the memory of the ClickHouse cluster, and there was processing there. Of course, processing 1 megabyte of data will not take any long time. Apparently, something took a few seconds. All right. Let's now look at the Spit engine, which allows you to run Spark operations on top of the YTsaurus cluster. Let's start with the fact that with the help of a special Spark launcher utility, let's say, enter a Spark cluster on the computing resources of our cluster. So we see that we have started some operation, and we can even observe it in the list of running ones. Here, we have an operation called Spit cluster, which is just running Spark. We can connect to the cluster using this pspark library software. It will often take some time for discovery to happen. And now we see that the pspark noticed our cluster, determined the version of the cluster library, and output a certain amount of auxiliary information. And now that we are connected to the cluster, we can run simple queries on top of it. For example, we can take and just read some table. Here, we are waiting for the data to be loaded into the Spark cluster. This takes some time, because certain transformations need to be performed. And so, we loaded the contents of the table into the memory of Spark cluster, and now we can work with it quite quickly. We can perform some simple analytics, for example. We can calculate the number of users who are married. We can calculate the number of different cities in which users are located. What we are doing here is simply using the pspark library, so any processing written using this library can be shifted to YTsaurus just if you move data from, for example, from S3, in which you would have previously had data in YTsaurus cluster. Finally, let's get acquainted with the fourth engine for processing the data in our system. We have decided. And we will solve the classical word count task with it. Namely, we will count the number of different words in a certain text, and the frequency of occurrence of these words, and then we will find the most popular words. Well, we'll start by preparing the data. We are subtracting. We have some files, including text. We will create a table with the following schema, in which each row will be sum. A row of the table, this will be some line of the source file, and we will have one column with the number of this line in the file, and the second column will be the actual contents of this line. We have created a table. Now we will take and write the data to the YTsaurus table. And now we are actually ready to take and run the calculation of the word count. So, let's see how this is done with the help of Python API. To run MapReduce on top of Python API, it is enough to implement just two functions, map and reduce, where the map describes the transformation that will be performed at the map stage of our operation. Just some one row of the table will be passed to it as input, and we describe how it will be transformed. In this case, we split our line by whitespace characters and generate one line of intermediate data for each word. That is, here we just say that we will have one line of intermediate data for each word of each line. Then, we will need to somehow aggregate this data in the reducer. So, when we describe a reduce function, we have to implement a function that takes two arguments. The first one is the key by which aggregation takes place at the reduce stage. In our case, this will be the actual word, so just a lot of lines will be transmitted to the input to the reducer, in which there will be the same word, and count will be 1 everywhere. And the second argument of the reducer is a set of strings that correspond to the keys. Accordingly, in our case, we simply get some word as a key, and as strings, we get all of these strings for some word. Well, in the output table, we will write down the same word, and as an account, we will write down the total number of occurrences of this word. Accordingly, then we will simply run the operation with our MapReducer, specifying the aggregation key for the reduce, and then sort our table by the number of inputs. We can go to the Operation tab again and look at our operations. Here, for example, is a MapReduce operation. I must say right away that on the operations page, you can find a lot of different parameters and counters that allow you to debug, for example, the performance of an operation, in particular, statistics overlays. We can see how much data was calculated from the disk, how long it took to read, the time of data decompression, and a very large number of other statistics. You can also look at individual jobs that were performed, how much they worked, and also look at their statistics. For example, if there is one job who has worked much longer than others, then with the help of statistics, you can understand why this happened. Actually, our operations have been performed, and we see that we really have an output table in which we found the most frequent and the rarest words. Finally, let's move on to the last part of today's talk. We're going to talk about how resource isolation is implemented in a YTsaurus cluster, namely how both disk and computing resources of the cluster are divided between many users who use it at the same time. And for the division of disk resources in YTsaurus, such an abstraction as an account is supported. Each node of the cluster, be it a directory or a table, is linked to some account, from which the resource consumption of this object is actually charged. Information about accounts can be viewed on the account page, and we see that we have different accounts, and we see, for example, that we have an account for analytics, which consumes only 27 kilobytes of disk space, with a possible 10 gigabytes. We see that there are 4 file system nodes located in this account, which is also important, because the file system nodes consume the master's memory, which is not infinite. And you can also manage accounts in the web interface. For example, we can change the disk quota of someone's account. Here it has changed. Also, of course, you can manage accounts not only from the web interface, but also from the YTCLI and language SDK. The account to which an object belongs is determined by the account attribute, which we can read or write from objects. For example, we can take a table that we have already looked at and see that it is being fought in the backend account. We can change this by setting an account to an analyst's account.
выставив аккаунт на аккаунт Analysts.
Now this
Теперь
table will be
эта
taken into
таблица будет
account
учитываться
in the
в аккаунт
analytics
Analysts.
account. Also,
Также
the
атрибут
account
аккаунт
attribute can
может
be
быть
set to a
выставлен как
directory,
директорию и
and in this
какой-то
case it will
атрибут на
inherit it. This
Это
means
означает, что
that all
все
new nodes that
новые
will be created in the
узлы, которые
subtree,
будут создаваться
some
в
directories will receive the
отделе
same account.
некоторых директорий, будут получать тот же аккаунт.
This is
Это удобно,
convenient.
например,
For example, you can
можно
set up
один
an
раз
account for the
выставить
home directory of a
аккаунт
certain
на
project
home директорию
once,
некоторого
and after
проекта, и
that,
после
all
этого все
tables or
таблицы и
nodes that
узлы,
will be
которые будут
created in this
создаваться
home
в
directory
этой
will
конкретной
automatically
директории,
be
будут автоматически
charged in the
печататься в
desired
одном
account. It is
Также
also
важно
important to
отметить,
note
что
that
аккаунты
accounts are
YTsaurus
hierarchical.
иерархические.
This
Это
means
означает,
that some
что
accounts may be
некоторые
subsidiary
аккаунты
of
могут
others,
быть дочерними
which
другим,
allows, for
что
example,
позволяет,
to allocate a
например,
certain amount of
выделить количество
resources to a
ресурсов
large
на
team, and
большую
the head of this
команду,
large
и
team will
руководитель этой
already
большой команды
redistribute
уже
these
распределит
resources
эти
between
ресурсы
smaller
между
teams that are
меньшими командами,
subordinate to
которые
him.
находятся у него в подчинении.
It is also
Также важно
important to
поговорить
talk
о
about
том,
how
как
computing
в
resources are
YTsaurus
classified in the
классифируются
YTsaurus,
вычислительные
and for
ресурсы,
this to
и для этого
YTsaurus.
в
Other
YTsaurus
objects
используются
are
на самом
actually
деле
used, which are called pulls, and information about them can be
другие
found in the
объекты, которые
scheduler overlay.
называются пулами, и информацию о них можно узнать на вкладке Schedule.
Each pool
Каждый пул
also
также
represents
представляет
some
собой
dedicated
некоторые
resources for user
выделенные
computing.
ресурсы для пользовательских вычислений.
Pulls are
Пулы
also
также могут быть
hierarchical.
иерархическими.
For
Например, вот
example,
тут мы
here we
наблюдаем
observe
некоторый
a certain
пул
pull,
MyPool,
in which a quota of 2
в
cores and
котором
512
выделена квота
megabytes of
в 2
RAM
ядра
is
и 512
allocated for some
мегабайт встроенной
calculations.
памяти для каких-то вычислений.
The pulls model in
Смотрите,
YTsaurus
в
is very
YTsaurus очень
rich, and
богатая,
various
и
types
мы
of
представим
guarantees can be
различные виды
configured.
гарантий.
For
Например, тут
example,
у нас
here
выставлена
we have a
гарантия
guarantee for
на
the number of cores
количество
and
ядер
memory at
памяти
the
в
moment.
моменте.
It
Можно
is possible
использовать
to use
интегральные
integral
гарантии,
guarantees
когда
when the guarantee is
гарантия
issued on.
выдается на
When a guarantee is
выдается
given
гарантия на
for the
интеграл
integral of the
количества
CPU
используемого
amount
CPU на
used
некотором диапазоне
over a
времени.
certain time range. We will talk
Более
in more
подробно
detail about the
о
pulse settings and our
настройках
scheduler
пулов
model
и нашей
in a
модели
separate
шедулера
webinar.
мы поговорим в отдельном вебинаре. И
Finally,
напоследок
I
хочется
would like to
сказать
say
о
about the
разграничении
differentiation
доступа
of
пользователей
user
к
access
данным
to data
и
and the
механизме
ACL
действия.
mechanism. So let's
Значит,
consider some table of home analysts users.
посмотрим некоторую таблицу Home Analyst Users.
Now it is
Сейчас
set up
она
specifically in
настроена
such a
специально
way
таким образом,
that the user
что
Petya, to whom I am logged in, does not have access to it from the next
у которого
window.
я залогинен из соседнего окна, нет к ней доступа.
That is,
То есть при
when I try to
попытке
open it, they will tell me that I
ее
cannot read
открыть,
its
мне скажут,
contents.
что я не могу читать ее содержимое.
This is
Это
due to the
происходит
fact
из-за
that
того,
the user
что у
Petya
пользователя
does
Пети
not have
нет
access to this
доступа
table.
к данной таблице.
Let's look at the
Посмотрим
ACL
на
attribute in this
атрибут
table
Пети
that describes the access rights to the object.
в этой таблице, который описывает права доступа к объекту.
It is
Он
empty,
пуст,
which
это
means that no one
означает
except
то, что в
administrators
этой
has
таблице
access
нет
to this
доступа ни у
table.
кого, кроме администраторов.
Well,
Ну, давайте это
let's fix
исправим
this
и
and
выдадим
give the user Peter the
пользователю
rights to read
Пете
this
права
table.
на чтение этой таблицы.
So,
Итак,
we
мы
added
добавили
rules to the ACL of the table that allow the user to
отдельной
read this
таблице
table,
правила, которые
after which the
разрешают
user
пользователю
Petya can
Пете
view its
управлять чтением
contents,
этой
but cannot
таблицы,
change it,
в
because he
случае
does not
чего
have write access.
пользователь Пети может просматривать ее содержимое, но не может его менять, потому что у него нет доступа write.
Such a
Такой
mechanism
механизм
is
является
convenient
удобным
for
для разграничения
differentiating access
доступа
to some
к
sensitive
таким
data
чувствительным данным
between
различных
employees
внутри
of the company.
компании.
In
В
particular,
частности,
a useful property of ACL is that
полезным
they can
свойством
be
ACL является то,
hierarchical.
что они могут быть иерархическими.
This
Это означает,
means
что
that it
можно
is possible to grant
выдать
access
доступ не
not to
на
each
каждую
table
таблицу в отдельности, а,
individually,
например,
but,
выдать
for
доступ на
example, to
чтение
grant
всего
read
дерева
access
файловой
to some
системы,
file system tree, which makes it more
что
convenient to
позволяет
manage rights
более
and
удобно
not think
управлять
about them
правами и
every
не думать
time
о
a
них
new
каждый раз
object is
при создании
created.
нового объекта.
That's
На
all.
этом в презентации все.
On this slide, you can see a list of contacts by which you can contact us in case of any questions. If you want to try something or want to improve something, write to me, write to Andriy, who is sitting next to me, visit our website, where you can sign up for a demo, view documentation, or go to our position. Visit our community chats, where you can discuss with us any questions you are interested in. Now we are ready to answer the questions you have accumulated during the report. Come on, I'm kind of on some kind of fun. I like the question, what kind of performance can be achieved from Cypress on reading writing table files? In fact, the exact fact that writing in Cypress is a process consisting of two parts. It affects both the meta-attribute, some metadata that is stored on the master, and the actual physical data that is located on the cluster nodes. And these are actually two quite different stories. If we talk about metadata, then the masters have some limited bandwidth. In general, Cypress is a scalable file system. That is, it is possible to deploy a certain number of Cypress shards, at the cost of actually some usability in certain scenarios, but fortunately, in most situations it is invisible. And if we use a conventional installation with one Cypress shard, then there really will be some restrictions on the bandwidth of the wizard, so we will not be able to execute a very large number of simultaneous requests to write a static table, for example. And with reading, the situation is similar, except that reading on the YTsaurus cluster from the master occurs from many threads, not from one, and also occurs not only from the leading master server, but from duplicate master servers, which also somehow limits the bandwidth for reading metadata, but this bandwidth is higher than the write bandwidth. If we talk about the second part, which is actually about writing physical data to a disk and reading from it, then the throughput of the compilation is unlimited and simply depends on how many nodes in the system, and which, for example, disks are installed on the node, or which network interfaces are supported. There's really no magic here. When you write some data to YTsaurus, it is simply written to several hard drives or SDs that are installed in the cluster. And the more efficient they are, and the more of them, the more bandwidth will be both read and written. I was told that there's some noise from me, so I'll ask you the following question. Yes, people are asking how to scale all this from a mono customer to a multi-tenant customer. As for scaling, there is, again, the part about the cluster nodes themselves and the part about the control plane. If we talk about cluster nodes, then scaling is completely understandable. Well, you can just buy more nodes in the cluster, make them more powerful, after which you will get more data storage space, more computing resources. If we talk about the control plane, then starting with a certain number of nodes, and frankly, with a fairly large one, what I'm going to say now is more relevant for clusters of 1,000 or more nodes. Up to this limit, you can simply not think about the control plane and increase the number of nodes, but starting, for example, with 1,000 nodes, various problems may arise with master servers and with scheduler. These problems are solvable and are actually solved by adding additional controller agents, if we are talking about scheduling, and by adding so-called secondary masters, if we are talking about a master. Instructions about what is possible, then how to do it, will be in our admin documentation, which are being prepared right now. They also ask about real cases in which it is possible to use YTsaurus. Well, in
Ну, на
fact,
самом деле в Яндексе
Yandex has a
есть
huge number
огромное
of
количество
different
разных
successful
штук,
examples
например,
of using
использование
YTsaurus in
в
very different situations.
очень разных ситуациях.
YTsaurus
YTsaurus
can be
может быть
used
использован
as
как
an analytics
платформа для
platform.
аналитики.
You can use
Можно
chit
использовать
and spit
YQL, чит
for
и
some
спит
kind of
просто для
analysis of big
какого-то
data
анализа
by
бэкграунда с
analysts
аналитиками
and
и
various calculations.
различных вычислений.
YTsaurus can
YTsaurus
be
может быть
used as
использован
such a
как
system
такая
for
система
processing
для
big data,
обработки больших
for
данных,
example, with
например,
the help of MapReduce.
при
You
помощи
can build
MapReduce
various
можно строить
pipelines that
различные
will,
пайплайны,
say, produce
которые
some
будут,
databases for
скажем,
some services.
изготавливать некоторые базы для каких-то сервисов.
For
Например,
example, we
хотим
want to
обучать
train
тип
some models,
моделей
or you just
или
have a service with
просто есть
data,
сервис с
and we take
данными,
as
и
we
мы
store
берем,
the output
мы храним в
YTsaurus.
YTsaurus,
For example,
например,
logs of
логи
the use of the
использования
service,
сервиса и
some
прочие
other
типа
data,
данные,
and launch
и запускаем
MapReduce
MapReduce
processing,
процессинг,
which will build
который
the state of
построит
our
стейт
service.
нашего сервиса.
Let's say
Скажем, это может
it
быть
can be
обучение
model
модели или
training
машинного
and machine
обучения,
learning.
может
It
быть
can
просто
just be
какая-то
some
различная
different
статистика.
statistics. There are
Есть
examples
примеры
of using
использования YTsaurus
YTsaurus
как
as a system
систему
for
для
real-time
реал-тайм
loading
загрузки и
on top
подтверждения
of
стиха.
dynamic tables. It is
Можно
possible to
хранить
store the
в
state of
различных
a service
таблицах
in dynamic tables
состояние какого-то
and change it
сервиса
depending
и
on some user
менять
requests,
его
and
в
thereby
зависимости
implement
от
the
какого-то
so-called load.
количества запросов и тем самым реализовывать так называемую LTP-нагрузку.
It's convenient
Удобно
that
то,
all of this is
что
in one
все это
namespace,
находится в одном
so in
namespace, поэтому,
particular,
в частности,
you can
можно
use some
использовать
kind of dynamic
какую-то
table to store some
динамическую
user-defined
таблицу
strips, and run on
для
top of the same dynamic table we
хранения
produce
каких-то логических
operations or
стейтов,
ICL in
и
order to do
поверх той
some
же самой
analytics on
динамической
top of this
таблицы
table.
запускать MapReduce операции или YQL для того, чтобы делать какую-то аналитику поверх этой таблицы.
We are
Мы
planning to hold some
планируем
more
провести еще
webinars, in
некоторое
which people
количество
who are already
вебинаров, на которых
actively
придут
using YTsaurus
люди,
will come
которые
and tell about
уже
their
активно
cases.
пользуются YTsaurus и расскажут про свои кейсы.
Let's clarify
Давай
a little bit about the
уточним
previous
немножко
one,
про
about
предыдущее, про
scaling.
масштабирование.
Dmitry
Дмитрий
asks,
спрашивает,
how to make it so
как
that
сделать
in
так,
this
чтобы
model,
данные
our
модели наши
multi-customers do not see
заказчики не
each
видели
other.
друг друга.
This is
Это
achieved
достигается как
precisely
раз при
with the help of
помощи
computing floors and
вычислителей
accounts.
пулов и аккаунтов.
It is possible for
Можно
each
каждому
customer to
заказчику
knock
выделить,
out, for
например,
example,
пул и
a
аккаунт, в
pool
котором
and an
будут
account, in
ограниченные
which there
ресурсы,
will be
которые
limited
этот заказчик может
resources that this
использовать.
customer can use.
Соответственно, он
Accordingly,
не
he will
сможет
not be able
тратить
to spend all the resources of
все
the
ресурсы
cluster
кластера
on
на
any of his
какие-то
actions.
свои действия.
If we
Если
talk about
говорить
computing
про
resources, then our jobs can,
вычислительные
well,
ресурсы,
the
то
user code that runs in
наши хабы
YTsaurus.
могут
It can run in containers in the container
использовать
system
код,
of the
который
port, which gives good
запускается в YTsaurus,
isolation
он может
between different
запускаться
user
в
processes on the same
контейнерах в
host.
контейнерной системе порта, что дает хорошую изоляцию между различными пользовательскими процессами на одном хосте.
We just run a
Просто
container with user
запускается
code
контейнер с
that has some
пользовательским
limits on
кодом, у
usage and
которого есть
memory,
какие-то
and the
лимиты
code
на
running in these
использование
containers
CPU и
does not
памяти,
interfere with each other
и
in any
доступы в
way.
этих контейнерах никак не интерферируют друг с другом.
If we
Если
talk about
говорить
disk
про чистые
resources,
ресурсы,
then
то
simply
просто
the
большой
master
сервер не
server
даст
will
вам
not allow you
потратить
to spend more disk
большее
space
место
in the
на
system than is
дисках
allocated in
системе,
the
чем
account.
выделено в аккаунте.
I do not know
Я не
whether
знаю,
you
ответил на
answered the
вопрос
question or
Дмитрий или
not,
нет,
but if
но
anything,
если
Dmitry
что,
will
Дмитрий
probably
спросит.
ask. There were
Еще было
also a
несколько
few
вопросов
questions about the
про
GPU.
ГПУ,
Do we use the
использование
YTsaurus for
YTsaurus
machine
в целях
learning?
машинного обучения.
In general,
Вообще
tell me
программировали
about the
еще
GPU and
что-то.
scheduler.
Да,
Yes,
у нас
we have
есть
large GPU
большие
clusters
GPU
that are
кластера,
built on
которые
top of
построены поверх
YTsaurus.
YTsaurus.
At the
На
largest,
самом
of
большом
course, more than
более
1,000 video
видеокарт
cards are
подключено.
connected. Our
Наш
scheduler is
шедулер
constantly being
постоянно
improved in order to
улучшается
better
для
pack
того,
toads
чтобы
on
лучше
GPU,
упаковывать
because in fact, it is quite different from the
добытые на
usual
GPU карты,
GPU
потому
and
что на самом деле
scheduling.
GPU шедулинг, он довольно сильно отличается от обычного.
With a
При
normal
обычном
scheduling,
шедулинге есть
there
такие
are more or less
более
perfectly
идеально
divisible
разделимые
resources,
ресурсы,
like
как время и
memory.
память.
In the
В
case of
случае
GPU
же
and
GPU
scheduling,
шедулинг
it
становится
becomes more
и
discrete,
дискретным,
because
потому
there are not very
что
many cards, and we need to pack user
карточек
jobs
обычно
by
много, и
nodes
нужно
somehow better.
лучше
We are
упаковывать
improving our scheduler
пользовательские джабы
so that it
по-разному.
better packs jobs in
Мы
such situations
улучшаем наш
and supports
тренировочник для
NVIDIA
того, чтобы лучше
drivers and all the
упаковывал
necessary infrastructure for
джабы
video
встречных
cards on
кластерах, и
cluster nodes that we have.
поддержка драйверов NVIDIA и всей необходимой инфраструктуры для видеокарт на узлах кластера у нас есть.
In
В том
particular,
числе в Яндексе
Yandex
есть
has
довольно
quite a
большое
large number of
количество
teams that train various
команд,
models on the
которые
GUI, which are just connected to the
обучают
YTsaurus cluster.
различные модели на GPU, которые как раз подключены к кластеру YTsaurus.
Well, there
Ну,
don't seem
кажется,
to be
больше
any
нет
more
вопросов.
questions. We can wait.
Можем подождать.
And if there is nothing
Если
new,
ничего
then thank you all
нет,
very
то
much.
всем большое спасибо.
Oh, wait.
О, подожди.
The question is this: is it possible to specify integrity constraints, triggers, sequences, and automatic field generation for a table? The only functionality that we have related to this is the so-called computable columns that are in dynamic tables. Then you can really specify some express on some of the columns, and they will be calculated as a function of other values in this row. We don't have triggers in the usual sense, but we have the so-called access logs of the masters, which allows us to receive in some systematic form information about all user actions with metadata. This can be used to build these own systems that respond to some changes in the cluster. For example, you can do some actions on each awareness of the table. Yes, Maxim clarifies that computable columns can also be in static tables, but there they are calculated once, when forming a row, when writing. Here. I would probably say that if there are no questions, then thank you very much to everyone. All new questions can probably be asked in our community chat. We will also answer there. Yes, thank you very much to everyone for coming. Use YTsaurus service, write to us in the chat and on GitHub. We will be happy to talk to everyone.